Okay, here we go. 7-3, logarithmic functions as inverses. You might give me a weird face at the beginning when we start this, but then at the end you'll be like, oh, that's why she's doing that, and that makes sense, okay? So we learned about inverses in the last chapter. So exponential functions are inverses of logarithmic functions. Same way, okay? Logarithmic functions are inverses of exponential functions. Okay, so you don't need to write all of this down, but you do need to write especially what's in the bubbles there. Okay, so I kept the variables a certain way for a reason. Y equals A times B to the X. And then we also have, and I'm going to put this up here and how we say it, because a lot of people have a tendency of messing this part up on how to say this. But it's log base B of Y equals X. Okay. Some people have a tendency of saying log base 5 times 3. It's not being multiplied. Okay. The log is being taken of that number. So that's why we say the log base B of Y equals X. Yeah.
So those are the same thing, like those two mean the same thing, but they're written.
Except for the A, but yes.
Okay, so the A is just like.
The A will, this is an exponential function that will, if we come across a situation like that, we'll deal with it a different way. But yes, this B to the X equals Y is the same as log base B of Y equals X.
Okay.
I'll show you how. Don't worry. So I have a lot of students, like I say, I guess they don't say it correctly, but then they also don't write it correctly. Notice how the base is a subscript. Y'all need to make sure that that sits down lower than the log, the Y, and the X, okay? Because in certain situations, I've had kids that have put this. So is that log base 5 of 25? Is that log of 525? Is that log of 5 raised to the second power times 5? I don't know, okay? Y'all start writing things and things start going all different directions. So make sure that I know, if you want me to know that is log base 5 of 25, you can write it that way. If you want to stay safe, which is the most accurate way to write it, is if you use parentheses, okay? So if you're like, I don't trust my handwriting, it's probably best to write it in parentheses, what you're taking the log of, okay? So why do we even need logarithms? All right. We've come across a couple of problems, especially from day one, that I've said, right now we're guessing and checking. When we get to logarithms, you won't have to guess and check, okay? I can ask you the question, 2 to what power gets you 4? And naturally, all of y'all were like, 2. Okay, but what if I asked you the question, 2 to what power gets you 5? You could probably say a decimal of some sort. All right, but that just doesn't rattle off like that, okay? That's what logarithms does. The majority of what you're going to do in logarithms will be in the calculator, okay, which is nice. But today we're just focusing on changing between logarithmic form and exponential form and back and forth. Okay, so how do we do that? So like I said, we're not dealing with A right now. we have b to the x equals y, and log base b of y equals x. So I call this around the world. All right? So it's weird, but you'll catch on here a little bit. So this tells me what I write next. Notice how the base of your exponent and the base of your log are the same thing. Okay, the base is always the base. All right? So log base b of y equals x. Log base b of y equals x. Okay? Same thing if I went backwards. Start with my base. B to the x equals y. B to the x equals y. Okay? So it tells you what you're writing next. That's why I call it around the world, because you're going around the world. So if you're going from exponential to logarithmic, you put a logarithm. If you're going from logarithmic to exponential, the log disappears. So kind of like that question you were asking about 26, you had something set up like that. So we're going to get to the point where we'll divide by that 2,000, and then we'll go around the world, and you'll have t. The good news about this chapter, what we learned today, what we learned Monday, is what we will use to solve on Wednesday and Thursday. Okay? Nice how it works out. Okay? So let's look at an example. %, I understand and I know that we can find the answer to that. It's 2. It'd be really stupid to go through and do around the world there, okay? Because that wouldn't get you your answer. That wouldn't get x by itself. It would get x by itself, but it wouldn't get us the answer that we can easily find here. But if we are just concerned about changing forms right now, okay, I'm going from exponential to logarithmic. So I'd write log. So log base 3 of 9 equals x. So that would have been a perfect situation for the question I asked you, 2 to what power gets me 5? Okay, then I have taken the x out of the exponent, and I can simply plug something like this into my calculator. Go to your calculator real quick. Yes, there is a log button that you automatically see. But that log button only does log with a base 10. 10 is like it's called your common base, okay? But that's like when we don't put 1 times x, it's silly. We don't put log base 10, it's silly. Okay, that's your common log, all right? So, go to math, scroll down, and you should see log base. That button in your calculator has been a latest update in terms of since I've been teaching. It used to not be in older calculators. So if you have an older calculator, let me know. I'll show you how to plug it in. Or you can use the Chromebook one. But that log base button adds a little base spot for you. Okay? So plug in the 3 and the 9 and press enter. So like I said, silly. We know the answer, 3 squared is 9. But if that would have been a situation that it was 2 raised to what power gets me 5, I would know the exact decimal.
So what is log? I still don't understand what.
What is log? Logarithms allow us to get that x out of the denominator, listen to me, out of the exponent. So we are not having to guess and check. The inverse of an exponential function is a logarithmic function. that allows us to then get x out of the exponent to solve for that value. This one seems silly right now because we know the answer to it, but we're going to get to somewhere we won't.
So, what is like log in the equation? So like, is it like a number? Is it just like a function or something? That's like just
It's a function. It's an equation. We'll get there. Yeah.
What does the equation look like?
Yeah. Like,
What does the equation look like for log?
We're the graph. We'll look at it.
okay.
Yeah, that's also in this lesson.
Okay.
All right, so we've already gotten that. Okay, so go ahead and change this one. Like I said, we know the answer to it.
So don't use your Chromebook one. Just do log. So in this case, you'll do log of 9 divided by log of 3. So I would say the base stays in the base, it's the bottom part.
So that's how you can put it in there. And if you use the Chromebook, I'll have that button for you. So we're just changing forms. So log base 4 of 64 gets me x. Okay. And I know we can find out what x is, but again, we're focusing on changing forms right now. Okay. Let's go backwards. So now I can't off the top of my head think log base 2 of what power gets me 3, but I can change it and I could definitely figure out what that is. So we start with our base, and we would say 2 cubed equals x. Yes, I know, we can solve for x. X is 8. But for right now, just changing forms. Okay? What did I say is our base if nothing is there? 10. 10 is your common logarithm. If nothing is there, your base is 10. So go ahead and rewrite that. Okay, so if you need to write it in there, you can. So 10 to the 4th equals x. Okay? Like I said, at the beginning, you might have been like, what is she having us do? And now you're like, oh, I just write it this way. Cool. Okay, this is just a stepping stone in solving for us. Any questions so far? Do I?
I'm still really confused. Like, I know what to do, but I don't know, like, what any of it means.
Okay, we'll get there. So what was a quadratic? What was a quadratic function?
The equation with x squared.
But what was it? What was it?
No, a parabola.
Okay, but what was it? I'm trying to show you that, did you like understand quadratics?
Pretty much, yeah.
Okay, same thing, this is just a new function.
So I could plug this in my calculator.
Huh?
I could plug this in my calculator here. Into my graph.
You can plug it into your calculator and get an answer,
As in a graph.
as in graph.
As in if I went to the graph, if I went to the stat plot and I was like, I want to know the logarithm of, I don't know, log base 2 times 16, I guess.
Of 16.
And then it would give me like an answer, give me plot on the graph.
Yeah, it is an actual function. Like, we are gonna graph it here in a second.
Oh.
So it's gonna be like, we'll type in, so right now, so we're not in y equals, but go to y equals. Okay, now go to math. And then let's make something up. It's perfect. Oh, because it gave you, put an x instead of 4. It's a function. So we have a different graph now. Just like, that's what I was saying with the quadratic. We have a graph for that. He said parabola, so that's gonna be the shape that we're gonna look at for a logarithmic function. Okay, so in this particular case, we have x squared equals 16. Okay, which we know x is 4. All right, so try 1, 2, and 3. I'll show you how we're going to deal with number 4 after. Try 1, 2, and 3. I'll show you how we're going to approach 4. Some of y'all have still not turned in your review from the last chapter. Make sure that gets turned in. That was a grade. And then get that 7-1 and 7-2 turned in. So really the only one that would benefit us from changing it from exponential form to logarithmic form would be number 3. Number 1 and 2 we could solve on our own. Can someone tell me how to rewrite number 1? We're just rewriting. Yeah.
Log base 7, 49.
Of 49, okay.
Equals x.
Equals x. Good. What about number 2? Okay.
Log base 2 of 8 logarithms.
I would like for y'all to get in the habit of using the parentheses. I'm not going to be crazy picky about it, but the lesson on Monday, can anyone tell me if that is log of x and then plus 3? Or is that log of x plus 3? Are you sure?
Probably.
So that could be log of x plus 3, Or that could be log of x plus 3. Okay? So parentheses are very important that you show me, hey, I'm taking the log of this number. Okay? Who can tell me how to write number 3?
Log 33 and 37.
Okay, again, we don't put 1 times x. We don't put x to the first power. We're not going to put log base 10. Okay? It's just one of those things we just don't write. Yeah.
Would it be counted wrong?
If I was grading, no. But then I don't grade your state test.
You should. Give us all 100.
Unfortunately, I don't. What?
I said you should, and then you should give us all 100.
You know, I feel like I've been in the giving mood a lot already this semester. I don't know that I could give more.
Woo!
I don't give grades, you earn them. But I definitely have given a lot more support this year in terms of late grades and all that jazz and
Yeah.
using a calculator on the entire test. It's taking everything out of my body. So, E. E is different, okay? In your book, you will probably see them still use this. And that's fine. You'll still get the same answer. I personally want you to get in the habit of when you start seeing E, you're going to use natural log. Or our students call it lateral nog. Look on your calculator for a second. Look right next to the button 4. See how it says ln? That's natural log. That's why I have kids call it lateral nog, because the L and the N are switched. I don't know why. But natural log has the base E. Okay? So just like on this last problem here, we didn't put 10. We're not going to put E. Natural log only has the base E. Okay? And it's weird because we're not going to really have a full-blown lesson on natural log until the last section of the chapter. I don't really understand that. But you'll still see it throughout this chapter. Okay? But if you run into natural log, and we'll talk about that here, like I said, in a couple sections, but it's another logarithm. It just has a different base, has a base E. Okay? And that one doesn't change. You don't have like the natural log of base 2 like you have the log of base 2. It's just base E. Okay? All right, let's go backwards. Go ahead and rewrite all of these in exponential form. Okay, someone that has not told me one of the last four answers. How do I rewrite number one? Okay,
6 square root of 0.
6 raised to the 0 power equals
Equals.
x.
Or, no,
I'm sorry?
my brain's not working today.
We're not working today. It's okay, it's Friday.
Mhm.
Number 2. You've already answered. Number 2.
Yeah, dang.
Okay.
Is it 2 to the power of 6.8 equals 0?
Equals
X.
x. Cool. Good. Number 3. Okay. So if you need to write the E in there when you're going around the world, go for it. The E cubed equals x. Okay. And the last one. Okay. 10 to the power what?
2.5.
Okay. Equals. Awesome. Okay. So in this particular situation, notice how every single one of my answers has x by itself. So what this process does is it gets x isolated so then I can solve for x. Okay. Some situations it's silly to do it. In most situations, this helps us to get x by itself. And the only way to make that happen between exponents is to do the inverse, which is a logarithm. Okay. All right, let's take a break and then we're going to graph these. All right, let's go ahead and finish this.
I'm struggling.
Hi. Did you have a good break?
Not really. I need to blow my nose.
You need to blow your nose?
Yeah.
There's usually tissues up here, but I have plenty of tissues. Step out into the hallway if you'd like.
I'm on the floor.
I'm a really good problem solver.
Huh?
I'm a really good problem solver. Solve your problem.
That's what problem solvers do.
I'm not really good at opening this box though.
That's not the problem.
Can't be good at everything.
You should solve it.
All right, so with the logarithmic functions, like I said, we learned how to graph exponential functions yesterday. Okay, so that is what is in blue up there. Just like exponential functions, logarithmic functions. I mean, with logs, you can have the base 10 is kind of your parent function. But the base can change. Just like it can be 10, it could be 2, it could be 12. It doesn't matter. Okay, so with this particular case, I went with 2 to the x because that's what we did yesterday. And remember, if we did 2 raised to the 0 power, we got 1. 2 to the first power, we got 2. 2 squared, we got 4. If we went backwards, we got 1/2, then 1/4, and so on. Okay? So if logarithms are the inverse of exponential functions, then I can simply switch my x and y's. Or I can reflect it over that y equals x line. And if this was 0, 1, I now have 1, 0. I have 2, 1, and 4, 2, and 1/2, -1. Okay, so see how those reflect over. Okay. So let's talk about the domain real quick from yesterday. My domain, this is going to keep going this way, and this is going to keep going that way. So my domain is all real numbers. But my range, we said there was what at 0? Asymptote. Okay? So our range is from 0 to infinity. So we can either write 0 to infinity, or we can put that y is greater than or equal to 0. So with a logarithmic function, if it is the inverse of an exponential function, and find the inverse and switch x and y, then we just switch our domain and range also. Because again, our range or our domain in this case starts at 0 and goes to infinity. Or x is greater than or equal to 0. And then our range is just going to keep on going up and down. So that's negative infinity to infinity. Okay, so see how they are inverses of each other. We switch our x and y's, which means we switch our domain and range. And we're reflecting across that y equals x. Okay? So everyone in your calculator right now, go to y equals and type in just log. Don't do log base, just log, which is on your calculator. On the main screen, right next to 7. Just do log of x. And this graph is a typical high school student. Why would I say that?
Boring.
No.
One side,
No.
short,
No.
blue. That would be that.
Lazy? I think that's the word I'm looking for.
-1.
Why did I say lazy? Because they don't want to continue drawing the rest of the graph. If you knew nothing about logarithms, I didn't show you the other side. I didn't show you what the graph actually looks like. And I I just told you to plug all of this in your calculator, and you did. I guarantee y'all would show me these graphs here. That looks like a square root graph to me. I don't know about you. Okay. So this graph actually keeps going all the way down that line. But on your calculator, it's like, meh, I'm just gonna stop here. Okay. So that's why I have to make sure that I show y'all how to graph that by hand. And those of you at home, that's what I'm referencing to. Okay. So not to try to add too many extra lines and dots on here. When we are looking at the exponential function, we had a horizontal asymptote. But if we're reflecting across that y equals x, we have a vertical asymptote. What would cause my vertical asymptote to move? What kind of transformation? Okay, so left and right. If I can move my graph to the left or to the right, I move my asymptote to the left or to the right. So with the exponential function, we said we move the asymptote if we move up or down. Now it's if we move left or right. Okay. So guess what's back?
Oh,
Yeah.
Same transformations, just a different function. Okay. Negative in the front reflects the x-axis, always. A is still your vertical stretch and compression. We can reflect the y-axis. That's an option now. H is still our left and right, and K is still our up and down. Okay, nothing has changed except for the function. That's why day one, when I taught y'all transformations, I kept it the same. So that way, literally every time y'all have learned a new function, it is the same exact thing. Okay, so let's look at this first example. First, I just want you to tell me the transformations. So which way does it move? Right 3 and up 4. Your parent function is just log the base and x. Okay. Question?
I'm almost scared to ask.
Okay.
But how much more difficult?
Logarithms?
Yeah.
That's a heavy question, only because for me, logarithms click because they're patterns. And patterns to me, if I can catch on to stuff like that, it's easy. And then there's some people that still in my pre-cal class are like, I hate logarithms, I don't understand it kind of thing. And I think that's just a personal. So if it's clicked for you, that's good, because it is all patterns, especially when it comes to like how we just did around the world. And then on Monday, we're going to do expanding and condensing. And then if you get those two things, then you can do solving. So it's like, I mean, if I can do one thing, it sticks with the others kind of thing. So I don't know how to answer that because, like I said, I'm biased and I think it's one of those things where it clicks, and then for some people it doesn't, and that's totally fine.
So what do we end up doing with this like pre-cal and stuff?
Do what now?
What do we end up doing with this like pre-cal?
The same exact thing.
Just harder? Just more?
I would say,
Yeah, pre-cal easy.
do what?
He said less. I said, yeah, pre-cal easy.
No. Well, what I've always said is that pre-cal chapter 1, 2, and 3 is algebra 2.
Oh, it's everything that we're doing here, but shorter.
Right. So algebra 1. Chapter 1 is functions. Chapter 2 is literally algebra 2 on steroids. It's got quadratics, polynomials, and rationals all in one chapter.
And it's a rational behavior.
And then chapter 3 is logarithms. And then chapter 4 and on is trig. So that's why I say you see it in pre-cal. I would say like the difficulty level of the type of problem bumps up, but the process is still the same. So, all right. So with all of your parent functions, you're going to have that 1, 0. Okay? Because if I plug in log base 4 of 1, of course it's going to be 0. 4 to what power gets me 1? 0. Okay? So for every problem, no matter what the base is, you're going to have that point 1, 0. Okay? For every problem, no matter what, you're also going to have, whoops. The base and 1. Okay? Because the base raised to what power is going to get you the base? Well, 1. Okay? So for every single one of those problems, you're going to have 1, 0, and then you're also going to have the base and 1. Okay? A lot of times you're only going to get probably 2 points on a 10 by 10 graph. If you think about it, the next point would probably be what? We've got 1, 0, 4, 1. What would be the next one?
I think you lost it.
Okay. We did it this way. What if I change this? Oops, not 2. So we've already done 4 to the 0 power equals 1. We've already done 4 to the first power equals 1. So if we do 4 squared, what do we get? 16. So the next point would be 16, 2. Then 64, 3. Okay? So we're dealing with some bigger numbers here. So 1 to 2 points is probably going to be plenty. That's all you're going to need. All right? Now my vertical asymptote is at 0. Did I move left or right anywhere? I'm going right 3. If I'm going right 3, that's where my new vertical asymptote is. Now, all I have to do is move both those 2 blue dots Right 3, up 4. And now I have my graph, which that went a little wonky there going down the asymptote. Okay, so that's why it's important to draw the asymptote there, so that way you can kind of just ride along that line. Okay, now 100% I understand y'all have graphing calculators, and 100% I know on a test and homework that's what you're going to use. But I can't let you leave my class without me showing you how to do this by hand. Okay. All right, let's try another one of these. I need to change these numbers because they're the exact same numbers. Let's do +1 and -2. Go ahead and graph that. Tell me my transformations and graph. So if we're going left 1, we need to make sure our vertical asymptote also moved left 1. So if I'm wanting to graph log of base 2 of x, I know I'm always going to have that 1, 0 in my base in 1. So this particular one, I could get another one out of it. Okay. I could go ahead and get 4, 2 as well. And if I really wanted to, I could get 8, 3. Okay. But like I said, just enough so you can see the actual graph itself is plenty for me. So then now I'm just going to move every dot left 1 and down 2. And I have my graph. Okay. Figure out the other points. It's almost like you have to think backwards. Like 2 squared gets me 4. So I'm going to plot the point 4, 2. 2 cubed gets me 8. That's why I did 8, 3. So you almost have to think backwards on that. It might help too if you do a table. That can also help. Okay. All right, let's look at one more. So this is going to cause what with our graph? A vertical stretch. And remember with vertical stretches and compressions, we multiply that value to which value? Our y, right. If we're vertically stretching or vertically compressing, we're multiplying it to our y value because that's affecting our y, not our x, just our y, okay? So we've already graphed our parent function from the last problem. We didn't move left or right, so my vertical asymptote stays. So if I have a vertical stretch, that means I'm going to multiply 5 by each one of my y values. Okay. So my y value here is 0, so I'm going to stay here. My y value here is 1, so 1 times 5 gets me 5. My y value here is 2, so that goes all the way up to 10. And then you can kind of see from there, which I won't have room to show it, but it is extremely stretched. It will keep going like that, and it'll round off eventually up there, okay? So remember, with vertical stretch and compressions, we just multiply our y value, okay? You can also get away with saying that if you have a reflection across the x-axis, you can also multiply your y values by the negative number, okay? Whatever is easiest for you. Okay. All right, let's go ahead and knock out our homework. Hopefully you don't have any this weekend.